Okay, so we're on to problem solving with quadratics. And the process here is going to be revealed as we start to do each question. The trickiest part here is always developing the equation. So in our first problem here, we have two integers differ by 12, and the sum of their squares is 74. Now an integer, that just means a whole number. So let's suppose that the first number is x. All right, now if the next number is different from it by 12, then we can express that as the next number is x plus 12. So we have two numbers that are different by 12. Okay. Then we have the sum of their squares is 74. So that means this number squared plus this number squared equals 74. So that's the first part, that's the tricky part. Reading the question, understanding what it's asking, and then developing the equation. Now all we have to do is solve this. The way we're going to solve this quadratic is we're going to fully expand it, move everything to the left, and we'll use our calculator. So here we have a perfect square, so we have an opportunity to practice a perfect square expansion there. A squared plus 2ab plus b squared. So the first term just stays as x squared. Here's our perfect square, this thing here. So we're going to have x squared plus 2 times a times b plus b squared. And then over this side we'll have 74. So we'll just simplify a little bit. We've got x squared here. We've got 2 times x times 12. That's going to be 24x. And here we have 144. All right, so all I've done is process that perfect square a bit. Now what we're going to do is start to collect like terms. These two are like terms because they have the same variable. All right, there's both terms of x squared. So I have one lot of x squared plus another lot of x squared. We have two lots of x squared. We have plus 24x plus 144, but we're going to take 74 from both sides as well to move the number over. So that equals 0 over here. 144 take away 74 is going to give me 70. All right, now this one's actually pretty easy. We don't need to use our calculator to solve this equation, so we'll just do this one manually while we can. Are there any questions so far? All right, so what we're going to do next is we're going to factorise it, and if you want, you could do the slide and divide method, but because we have an equation, we can do anything we want to both sides, and I'm looking at this and going, 2 is common to all of them, so I'm going to divide both sides by 2. So if I divide both sides by 2, 0 divided by 2 is 0. Over here, when I divide all of that by 2, this term becomes x squared, this term becomes 12x, and this one becomes 35. And that's nice and easy for us to solve. Now, what it technically means, it doesn't mean that this equation is equal to this equation. Those are different equations, but it means the solutions to this equation are equal to the solutions to this equation. So two numbers that multiply to give us 35 and add together to give us 12, that's going to be x plus 7 times x plus 5. Apply the null factor law. Okay, now we need to answer the question. We developed the equation, we solved the equation, but now we need to answer the question. The question is, two numbers differ by 12. Find the numbers. So, if the number is minus 7, then the other number is going to be minus, so we can call that x1, x2. The other number is going to be minus 7 plus 12. They differ by 12. So we can have minus 7 or positive 5. All right? Those numbers differ by 12. There's 12 difference between them. And when we square them both and add it together, we'll get 74. Okay? 49 plus 25, 74. All right. if the number is minus 5, then the other number is going to be minus 5 plus 12, which gives you positive 7. All right, and so both, either that's the set of numbers that satisfies this equation, or that's the set of numbers that satisfies the conditions of the problem. Okay, so that's question 1. Let's move on to question 2. We have the sum of a number and its reciprocal is 26 on 5. Find the number. So we're going to set the number to be x. Okay, that's our unknown. Our unknown is x. And we're going to add to this number its reciprocal. Now the reciprocal means you flip the fraction. That's what reciprocal means. We should remember that from perpendicular lines. So at the moment this is x on top of 1. So if we flip it, it's going to be 1 on top of x. So we have the sum of a number and its reciprocal is 26 on 5. Find the number. Alright, so what we're going to do here is solve this quadratic equation. And we did start to see these in 2a, in the later parts of 2a. When we have x as a denominator, we want to get rid of the denominator, always. The way we get rid of the denominator is by multiplying both sides by that denominator. So I'm going to times both sides by x. Alright. On the left-hand side, it's going to distribute. We're going to have x squared, and then we're going to have x times 1 on top of x. X times 1 on top of x. That gives you x on top of x, which is positive 1. On the right-hand side, we've got 26 on 5 multiplied by x. Okay, so we've gotten rid of the denominator. Now we're going to move everything to the left-hand side. Plus 1, and then take 26 on top of 5x. So I've moved it over, and I just want to draw a skill out here, is that the terms aren't necessarily written in the order ax squared plus bx plus c, which is the general way we present a quadratic. So that means we need to rearrange it. The first term is the x squared term. The second term is the x term, and we need to include that whole coefficient with it. So we have minus 26 on 5 times x, and then the last term is the constant term, which is plus 1. Now here we could probably solve this one algebraically as well. I'll point to an algebraic path you could follow, but from now on we will use our calculator. So if I was going to solve this algebraically, I'd want to get rid of that denominator of 5 there. And we've seen if we want to get rid of the denominator, we would multiply both sides by x. So if we multiplied both sides by 5, this term on the left-hand side, we would have 5x squared, take 26x plus 5. And on the right-hand side, we'd have 0. And we could do the slide and divide method there, okay, to find the solutions. All right. Should we do it, or should we use our calculator? Maybe we will. When we can do them, maybe we will do them. So if we multiply through by 5, we'll have x squared take 26x plus 25 is 0. The multiples of 25 that add up to 26 are going to be minus 25 and minus 1. Okay, minus 25 times minus 1 is positive 25, and minus 25 plus minus 1 is negative 26. And then, because we multiplied through by 5, we have to divide by 5. Okay, we write the fraction in simplest form. 25 divided by 5 is 5. And x take 1 on 5, that doesn't simplify, so we move that denominator up in front of this x. 5x take 1, and then we apply the null factor law. We get x is 5, or 5x is 1, x is 1 on 5. And so these are the numbers, right? The number and its reciprocal. If the number is 5, the reciprocal of 5 is 1 on top of 5. Really good. Okay, we will draw out those calculator skills in a moment, but you can put in the calculator at any stage, you can put this equation in, you can put this equation in, we'll reveal it in a moment. So that's question 1 and 2. Let's go on to 3. We'll definitely use the calculator here. The product of two consecutive even numbers is 360. So this is question 3. So, if our number is x, then the next even number, because they're even numbers, so consecutive means in order. So if our number is x, the next even number is x plus 2. All right? For example, an even number is 6. The next consecutive even number is 2 larger than 6. All right? It's going to be 8. 8 is 6 plus 2. All right? So if our first even number is x, the next consecutive even number is x plus 2. Now we're told the product of these, so that means when you multiply them together, it's equal to 360. All right? The product means multiplying. And so then we're solving this equation. On the left-hand side, we'll expand it using the distributive law. We'll have x squared plus 2x equals 360. We'll move the 360 over. And now we're going to solve this equation using our calculator. So what we'll do, the best way to solve a quadratic, there's multiple ways, but I think quadratic, the best way to bring up the solutions is go menu, equation solver, and it's a polynomial. That's the unit that we're working through at the moment. And the degree is 2, because we have x squared. And then all we're doing is putting in the values of a, b, and c. So we'll put in a is positive 1, b is positive 2, c is minus 360. And the answers we have is x is 18 or x is minus 20. Okay, now to answer the question, it says find the numbers. Okay, so if the number is 18, then the next consecutive even number is positive 20. And 18 times 20 is 360, the product of those two consecutive even numbers. If the number is minus 20, the next consecutive even number is minus 18. You're moving 2 units closer to 0, and minus 20 times minus 18 is positive 360. All right, does anyone have any calculator questions yet? Okay, keep going. Number 4. All right, the number of diagonals on an n-sided polygon is given by the formula d equals n on 2 times n take 3. So firstly, a polygon, it just means a shape with many sides. All right, so a triangle is a 3-sided polygon, square is a 4. All right, and so any number of sides, and then a diagonal. So in a square, for example, we have 2 diagonals. All right, they're going across the shape. All right, so we have a polygon has 90 diagonals. So using this formula here, what we're going to have, we're given the formula a bit here. We have, this is the formula, d is n on 2 times n take 3. And we're told the number of diagonals is 90, where n is the number of sides of the polygon. And it says how many sides does it have? So we have to find n. We're solving this equation for n. Now, because it's an equation, all right, generally my preference, you don't have to do this at all, but my preference is to write it like this, right? So n on 2 times n take 3 equals 90. I prefer the equation on the left-hand side, the terms on the left-hand side, and then we're going to end up with 0 over here. So what we'll do is we'll expand this. So if we distribute this, if we have n on 2 times n, that's going to be n squared on top of 2. Now what's technically going on there is we have n on 2 times n by itself. Anything by itself is always on top of 1, right? So n times n is n squared, and 2 times 1 is 1. 2 times 1 is 2. So we have that denominator of 2. Same with this one, we're going to have 3n at the top and 2 at the bottom. Okay, 3 times n at the top, the denominator stays as it is. And it's negative, so that negative stays there. I'm going to move the 90 over to the left, equals 0, and now we'll put this in equation solve. So our value of A, positive half, our value of B, negative 3 on 2, our value of C, minus 90, and we'll solve for n. So we're going to go 0.5, negative 1.5, negative 90. So can you, I'll get you guys, make sure you know what you're doing on your calculator. Okay.
What's negative 3 on 2?
What, negative 1.5? Is that what you're asking? Yeah. You can type it in as a fraction. You can type it in as a division. It will all still work. All right. So, one thing to point out here is we have a negative solution. Now, what we're doing is talking about the number of diagonals in a shape. So, that means the negative solution, we have to reject it. It's rejected because you can't have a negative number of diagonals in a shape. All right, it always has to be a positive number of diagonals, so we reject the negative solution. Now, the reason why we sometimes reject negative solutions will depend on the context, and it's going to become very clear in the examples we work through in a moment. All right, beautiful. Number 5 is a really good question. So we have the length of a rectangle is 4 centimeters longer than its width. Okay, so here's a rectangle, and we have this length is 4 centimeters longer than its width. So if its width is x and its length is 4 centimeters longer, then its length is going to be x plus 4. All right. So let's have a go at developing this equation. Here's the parameters of the rectangle, and we're told that its area is 26 centimeters. Can anyone develop an equation here for me? Can anyone see it?
X into x plus 4 equals 24.
Very good. The area of this rectangle would be x times x plus 4. All right, area of a rectangle is always length times width, and this is equal to 26. All right, get you guys to expand it, solve it. So we've got irrational solutions. I did. I didn't put it in properly. 1 for minus 26. All right. So look at that. That's very interesting. So in our calculator, we've got x equals minus 2 plus root 30, and they've rounded it for us, 3.477, or minus 2 take root 30, which is minus 7.477. Okay, now what are we talking about here? We're talking about the length of a rectangle. So what does this mean for our solutions? Length of a rectangle. One of them doesn't match the problem.
It can't be negative.
Can't be negative. A length of a rectangle can't be negative, can it? That doesn't make sense. Always has to be positive in magnitude. So we'll reject the negative solution. And if we're given a unit here, we're told centimetres, then we should issue centimetres in our answer. So the width of the rectangle is 3.477 centimetres. Really good. Okay, with the next one, I'm going to show you another way we can use our calculator that you'll probably use more frequently. Okay, so let's go to number 6. We have a rectangular box has a square base. Its height is 1 centimetre longer than its base side. Alright, so what that means is we have a square base and we're told it has dimensions x in the base. And then its height that it goes up, sorry I might rub that out actually, its height that it goes up like this is 1 centimetre longer. So this length here is x, but plus 1. So those lines, double lines, mean all of those lengths are the same. The base is the same. Alright. The rectangular box has a square base. Its height is 1 centimetre longer than its base side. The total surface area of the box is 240 centimetres squared. Show that the total surface area is given by this equation. Okay, so surface area, what that means is you've got to find the area of each face and add it all up together. So what we have here is we have the base, we have the top, and then we have how many walls? 4 walls. Okay. So the area for the bottom is just x times by x. So the base is x squared. The top is going to be the same. X times x. The top is x squared. And the 4 walls are going to be 4 times. And then each wall is x times by x plus 1. Okay, so all we have to do first is bring all that together. So we've got 2 lots of x squared here. We've got 4x squared plus 4x here. Now I would encourage you to do that sort of slowly. We'll go 4x, and then we'll go 4x times x is 4x squared, 4x times 1, 4x. And we'll collect that a little bit more. We'll get 6x squared plus 4x. Okay. Now, so that's the area function. So that's why they've got the area of the shape, the surface area, is equal to some form of x. Now, one thing to point out here is that part A says, show that the area can be given by this function. Okay, so in a test, in the test situation, there will be a question like this, where you do have to show that the function can be expressed like this. All right, so there's tricky marks to get there. Hopefully we can get them. But if we can't get them, we can still answer part B, because you can use the equation. Find the dimensions of the box. They've given you the equation, and so we know that the surface area is equal to, says it in the question, 240 centimetres squared. So that's the equation we're solving. We'll move it to the left, and this will be the equation that we solve. Now I want to show you a new strategy. I think we may have mentioned it before, but for using your calculator, this is how you can solve any equation. So we'll go to our run match. So that means go to the main menu and go to run. Our basic setting in the calculator. All right. And what we're going to press, I'll give you a few instructions here. We'll press Option, then Calc. Okay, so Option is below F2. Calc is going to correspond with F4. And we're going to then press Solve N, which corresponds with F5. All right, and if we press that, it pops up like this, Solve N. Now, here's what you type in. You're going to type in the equation you want to solve, a comma, and then the variable x because we're solving for x, and then close the bracket. So in this circumstance, we're going to type in, we've got solve n, we've got a bracket open. Here's the equation, 6x squared plus 4x, take 240, equals 0. You have to type in the equals part as well. All right, now the equals is shift dot right at the bottom. Okay, shift full stop right next to the 0. That'll bring up the equals. Equals 0. Then we have comma x because we're solving for x. Now the comma is below the cos button. Can anyone remember why? Cos. That's where it goes. So type all that in. And when you press, if we're up to that stage, see, I don't want to rush you guys, but if you press equals, it'll give you a warning. Many solutions exist. Yep, we know. You just press exit and it'll come up with both answers for you. So I didn't type it in after that. 6, 4 minus 240. So we've got x is 6 or negative 6.6 recurring. We reject a solution.
Oh, you do that as today.
So then, yeah, what did you get here? 18 on 19 on 3? 20 on 3. So we reject the negative solution because we're talking about the length of a shape. It can't be negative. Now we have to read this carefully as well because this will pop up in the test. Find the dimensions. Okay, so the dimensions of this box are going to be the base times the base times the height. So to answer properly, dimensions are 6 by 6 by 7 centimeters. Okay, the base is 6 times 6 times 7. Excellent. All right, last one, and then we'll stop and we'll retry these 1 to 7 questions for homework. We have an open box, can hold 80 centimeters cubed. So it looks like this. And you're going to fold it up, and we know that this distance here is 3 centimeters. 3 centimeters on all those sides. Okay, its volume is 80 centimeters cubed. It is made from a square piece of tin plate with 3 centimeter squares cut from each of its 4 corners. Find the dimensions of the original piece of tin plate. Okay, so if this length is x, all right, and we're folding it up, this length here is x, so it's like x is the base, right? X is the base. Then when we fold it up, here's what it's going to look like. We'll have x at the bottom and we'll have 3 here. Okay, so then the volume of this shape, the volume of a 3-dimensional prism, x times 3, so that's 3x squared. Right, 3 times x is the volume. And the volume holds 80 centimeters cubed. So we have 3x squared equals 80. Now this is one we can solve very easily using algebra. What you might be inclined to do is go 3x squared, take 80 as 0. You'd have a is 3, b is 0, c is minus 80. You could do that. That would work. Okay, you could type that into your polynomial solver or your equation solver. Let's look at how we can solve it just using simple algebra. First, we're going to divide both sides by 3. Now, 80 divided by 3, what's that going to be? 23.3 recurring. So we'll leave it like that for now. And then we will square root both sides. And of course, the negative root 80 on 3 is a negative dimension, so we'll reject that solution. But this one, we can just type in, what's the square root of 80 divided by 3? That's our solution that we've found algebraically. So 5.163. Now, I'll always write 4 figures, and then the fourth one we round, 5.16. So that's the value of x. Well, we've got to answer the question. Find the dimensions of the original piece of tin. Well, the original piece of tin was this long and this wide. So that means it's x plus 3 plus 3. So we're adding 6 to that. We'll get the original dimensions were 11.16 by 11.16 centimetres to answer the question. Really good. So I'll stop there. And for homework tonight,